In this video, I will show three different brands. The TP-Link Tapo, the dahua dual illumination IP camera, which is PoE, so wired only. This one is wireless or wired, and the Wi-Fi OEM Chinese battery solar operated camera. This one uses the HeyUCam app. The idea is how to use the ecosystem from the Tapo, which includes smart plugs or smart switches, very good price, very economical. How to use it in order to turn on and off these switches based on the scenes that you may create using programming. For example, let's say that you have this Tapo installed in the back patio. As soon as it detects smart motion, crossing a line or entering into a determined zone that you program, it will send a signal to the smart switches that you may have installed in your house, and it will start a sequence of turning on and off different areas. For example, let's say that this is in the terrace. You turn on after the detection. After, let's say, 5-10 seconds later, then you can turn on the hallway or the kitchen, and you start a sequence of light that is a good deterrent for the intruders. It's telling the intruder, we notice your presence in my area, because the camera detected. So actually, if you have a Tapo that's a part of the ecosystem, it's quite useful, especially now that these systems, including the Matter certification, which is a threat as well, indicating that it's a mesh, communicate low power between different switches that you may have from the Tapo lineup, of course, including the 1.5 certification, which they will add more and more cameras eventually. But right now, there's only a couple of cameras. The importance of this Matter threat certification, at least for the lightning communication, is that you don't need a hub, like in the case of the Zigbee or Z-Wave. So basically, if you have a Tapo, no problem. You just program SIM, and that's good. But what is happening if you have a dahua camera and you want to use a smart switch that you already have it, or you want to buy it at a good price, or even this solar Chinese camera, battery operated? Well, not necessarily you may upgrade any camera. It needs to have, in this case, it's a night color camera. That means when it detects motion during nighttime, it will turn on the LED and keep it in a steady light, and that will start a sequence to communicate with the Tapo. So that's the part of the program, the part of the video that I will show today, how to modify the camera in order to add the capabilities of Tapo in any camera, full color camera. This one as well has the white LED here, and it will turn on. Unfortunately, it will turn on even during daytime, but remember that this light switches has scheduling as well. So you may tell, even though it turns on during the daytime, you are creating a schedule within the scenes, so it should be no problem. So remember, you may add it to any of camera full color, or have the capability of turning on white light during detection. This particular one, it's steady white light when it detects, and it only can be controlled by the motion when it detects motion. This one has white light, but in this case it's not steady white light. It's pulse, it's on off, on off, on off, on off, and that will affect how it's needs to be the modification that you're going to be presenting. You need to consider how it's the system operating the camera that you want to modify. I even have a video, a previous video, in which I show how to add the sensing, or at least the detection process, how to add a relay, an external relay, so you don't need to open the camera and you can void the warranty, or even if you want to open it, how to modify. Especially that was for the dahua and IMO camera as well. So let me start with how it works with the dahua camera and show it the circuit and explain how it works. Here I have a dahua dual illumination modified already, so that's why it was open and included everything inside the camera in order to communicate with the Tapo smart switches that I may have in the house, in my property, during the detection. This particular camera, this is a wired camera. It's actually a PoE right now, but inside you need to extract the voltage in order to powering the Wi-Fi module. This is a tear down that I have from the Tapo smart plug. This is a tear down, and what you need to look for, it's this module. This is a Wi-Fi module. Actually, it's here. So this is the only thing that you need, is this particular module. This module will only have power. It works with 5 volts. So it has 5 volts needed in order to operate. This camera, it's 12 volts. At least I can extract the 12 volts and have a step down regulator in order to power this system, the 5 volts. Or you may find some cameras that you're working with, you may find most of the IC integrated circuit, they use 5 volts as well. So try to look at the regulated voltage, 5 volts, and you are okay just to power this particular module. The way it works, well, actually everything is inside the camera. As I mentioned, this is it will become the transmitter for different switches that I may have around my property. And what it does, this particular camera, as I mentioned, during daytime it will not turn on the white light that is included here. I just put a cover on the lens because I don't want to turn on the light. At least it will not happen anyway because it's daytime. I have a good illumination here, but in order to simulate the detection, I just uncover, and that will be a change in light, and that will turn on the light. That's the only objective that I'm looking for. It's turning on the light. The light will signal the triggering of this module, and that triggering will be enough to send the signal to the different switches that I may have configured within the ecosystem that I created with the TP-Link Tapo. So basically, the camera is full color. As I mentioned, very important, needs to be full color, or at least that the white light turns on during detection. This particular camera has 2 modes. You may record full color all night long, but that's not the case that I need. In order to transmit the signal, it's only during smart detection, either crossing a line cross or entering a particular zone that I already programmed. And as I mentioned, it's already on the Tapo app. You just program the scene that you want to create, the light show, as I may call, as a good deterrent for the intruders. So let's do the the procedure of, I will remove the cover, and that will turn on the light, and you will see that I have programmed these two switches. I will turn on the first one. Let's say this is the terrace, and then I have inside my house, for example, in the hallway or in the kitchen, it will turn on. This is only after 5 seconds. It will turn on off, then stay on for 5 seconds, and then everything turns off. So you may decide how you want to program during the scene, the program of the scene. But I only using, for example, a couple of 5 seconds, that's mostly 10 seconds. But normally you program for 3 minutes. After that, everything turns off, and the camera is waiting for the next intrusion, the next detection. So let's remove the cover, and as I mentioned, the change in light will turn on the light, not because of detection, but let's do it. As you can see, it's turning one of the, let's say, the terrace. Then the hallway turn on and off for 5 seconds, and then will everything turn off. Eventually the light, if there's no motion, will turn off. So basically that's the modification that I do it in this particular camera. As I mentioned, as you can see, the light stayed on at all time during the detection, so there's no oscillation in the on off, like the other camera that I'm gonna be showing you, the battery operated camera. Remember, this one in particular has inside, since it needs 5 volts, you need to have a regulator. I'm not using a linear, I'm using a switching regulator. If you have this space to include it, that will be the best alternative. If not, you may use a linear regulator, but remember that you need to dissipate the heat from the 12 volt to the 5 volts regulation. So that's important in case you don't have the space to include the switching regulator. This is the electronics that goes inside the cameras for both the dahua and, in this case, the battery operated solar camera. This is a Wi-Fi, and what we have here, it's since this camera is battery operated, it's 3.2 volts. We need to convert the power to 5 volts because the Wi-Fi module works at 5 volts. So I converting the 3.2 to 5 volts to operate the circuitry. The difference between dahua or wired cameras or non-battery cameras like this one is that in order to preserve the battery, the white light is on the flashing mode, so it's on off on off on off. Different from the dahua, which is a steady voltage at the lamp. The white lamp, white light, it's keep on at all time. So there is a different approach on how to design this circuit, and it's basically they add what is called non-retrievable. It's part of an oscillator, like a one-shot circuit, that when it receives the triggering from the camera, because it detects motion, it goes into high and keep it high until the process finish. The heart of the circuit the process is this part. Actually it's an oscillator. The oscillator, when the power, as I mentioned, is high, it's providing power to this oscillator, so it start of course oscillating, on off on off on off, and there is a particular reason for that. This switch, which it's actually used for turning on and off the light to be controlled, is being used as well for resetting or setting up the switch when the initial settings that you keep pressing for several seconds. After that, it enters into the setup mode or factory reset. So you want to avoid that in this particular circuit, and that's why I'm using a stable oscillator that keeps on off, just trying to avoid the keep it pressing by doing this. So that's the action that it's been doing with the oscillator. In this case, I'm using the 555 timer, the non-retrievable for the battery, and for the dahua I don't need the non-retrievable. As mentioned, it's always on high. The steady light is steady, so it not change until it's finished, of course, the detection. But that's enough to turn on the scene that I programmed within the system, the Tapo smart switches. So the reason for that is that one of the pin of the push button is on what is called the pull up logic, is in order to avoid floating with an open contact. So floating means that it could be either a high or a low, 0 volts. So in order to avoid that, I'm using the oscillator. Okay, let's test it. Let's walk in front of the camera to make here you can see it's starting this, it's then reduce the pace. As you can see, this is as mentioned, the hard, this is on high all the time, and this is changing the state. Okay, so the program that you have, it will then start the sequence of the scene that you program. The timing is regarding the RC, the resistor, and the capacitor. After it ceases, there's no more power to the non-retrievable, as well as the oscillator is repeating itself, the process until it's finished. But the more you get it, it's the better to deterrent have that kind of action with the lightning. If you have any other questions regarding, I will include the diagrams on how to connect everything. Remember that depends on the camera, has different characteristics, so you may need to change the value of the resistor, at least for the RC, the timing of the RC within the timers, but basically it's the same. It applied the same. So that's all you need. Let me know if you need more information. Thanks.